Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haiman Sakawi bin Hairul Segiman. I'm the group leader for Group 3 for class RAS 1201D. Me and my team will be presenting a lab report for two experiments, which is experiment 1, basic measurement, and experiment 5, hook law. We will go first to experiment 1, basic measurement. For this experiment, there are two objectives. The first one is to determine the volume and density of ball bearing. The second is to determine the volume and density of glass block. Under methodology for the experiment, for the apparatus, we have 5 apparatus. The first one is vernier caliper, second micrometer screw gauge, third weighting scale, fourth ball bearing, and the fifth is the glass block.
So next, my name is Muhammad Hakimi and I will be continue the presentation of procedure. The procedure A is micrometer screw gauge. The first one is the zero error was determined. The next is the diameter of the ball bearing was measured. The next step 2 was repeat at least 3 times at different position of the ball bearing. Next is that all the data were recorded in the suitable table. Next, the actual diameter reading was calculated with the zero error obtained early taken into the consideration. Next, the weight of the ball bearing was determined and also the density of the ball bearing was calculated. Alright, next I will continue to the next procedure is procedure B, vernier caliper. The first one is the whole number of small division on the fixed part of the caliper that are to the left of the zero mark on the vernier was counted. The size of the object will be to the nearest number of full millimeters. Next, the first mark of the vernier that line up with the one of the mark on the fixed part of the caliper was found. The mark on the vernier tell the number of fraction of the millimeter will need to complete the estimate size of the object. Next, the zero error of the vernier caliper was determined. The length, width, and thickness of the glass block was measured using the vernier caliper. Step 2 was repeated 3 times at the different position of the glass block, and also all the data was recorded in a suitable table. The actual measure was calculated with the zero error obtained early taking into the consideration. So the weight of the glass block was determined and also the density of the glass block was calculated. Alright, this is our result in experiment. The left side is micrometer screw gauge and also the right side is vernier caliper. So the next one is analysis of the result experiment. For the first question is calculating the volume, uncertainty for the volume, density, and also the uncertainty for density for the ball bearing. Next, the second question is calculating the volume, uncertainty for the volume, density, and the uncertainty for density for the glass block.
Hi, my name is Muhammad Syamil Hazim bin Suhaimi. So next we will see the discussion. For the first table, we measure the diameter of the ball bearing using micrometer screw gauge. We firstly determine the zero error to the instrument, in which we have determined it to be 0.05 millimeter. This means the reading for the micrometer screw gauge that we get is the observed reading. We must subtract it with 0.05 millimeter to get true reading. The existence of zero error are mainly due to fault in the instrument from wear and tear that cause it to skew from the original scaling. Based on that, the average observed reading for the ball bearing diameter is 18.99 millimeter. Using this, we can also get the average observed reading for its radius by dividing it with 2, which gets us 9.56 millimeter. We then apply a zero error correction to the average observed reading for both diameter and radius to get the true reading, which are 19.85 millimeter and 9.52 millimeter respectively. Next, for the second table, we measure the length, width, and height of glass block using a vernier caliper. We first determine the zero error for this instrument, to which we determine it into zero error. From this information, we do not need to apply zero error correction we do not toward our reading. Therefore, the observed reading and the true reading for this table will have the same data. From our measurement, we have determined that average observed reading for the length is 11.47 mm, width 2.25 mm, and the height at 6.17 mm. Since zero error do not apply for this instrument, then the true reading will be the same well. From the data we gather, we are able to calculate the volume and density of both the ball bearing and glass block as well as their uncertainty, as both of our instruments are unable to get the exact reading, only to in areas. For the ball bearing, we can get the volume by using the formula that is shown on the screen, in which R is the radius of the ball bearing or ball bearing. From our calculation, we get the answer like this. Meanwhile, to get the density of the ball bearing, we use the formula as shown on the screen, in which mass of the ball bearing we get 28 gram. Therefore, the density of the ball bearing we get this answer on the screen display. Next, to calculate the uncertainty for the volume of the ball bearing, you use the formula on the screen display, where the n equals to 3 is the smallest reading on our instrument able to get. For the micrometer screw gauge, it is 0.01 millimeter, and V stands for volume, which is therefore you will get the answer like that. To calculate the uncertainty for the density of the ball bearing, we use the formula like on the screen display, where M is the mass of the ball bearing, which is 28 gram, is the smallest reading for the mass, which is 0.1 gram. V is the volume, and its uncertainty for the volume P is N for density. From this, we will get the answer like the screen display.
For the glass block, we can calculate its volume by using the formula shown on screen, which is the total multiplication of the length, width, and height. We will get the total as shown. For the density, meanwhile, the formula is the same with the ball bearing. With the mass of the glass block weighted at 304.29 grams, therefore we get the result shown. To calculate the uncertainty for the volume of the glass block, meanwhile, we will use the formula shown here, in which delta V stands for the smallest reading of the instrument, which is 0.01 cm. The result that we get is here. To calculate the uncertainty for the density of the glass block, we use this formula, where M is the mass of the glass block, which is 304.29 grams. Delta M is the smallest reading for the mass, which is 0.1 gram. V is the volume, and delta V is the uncertainty for volume. P stands for density. From this, we will get this result. While performing this experiment, some sources of error have been detected by us. Firstly, the operator must check the zero error on the instrument before using them. The instrument may have been skewed from its original reading from continuous use. Failure to do so could give incorrect reading. Secondly, the operator must take good care to prevent damage from happening to the instrument. For example, one click is needed when rotating the ratchet from micrometer screw gauge. Any more could cause damage to it. Thirdly, the operator must take extra care when trying to read the scaling to avoid any error on the operator part in getting the wrong reading. Multiple attempts should be made in order to get the most accurate reading and also to detect any false reading, especially if two data from two different attempts differ massively. For the conclusion on this experiment, the volume and density of ball bearing have been determined, which are 3614.09 mm cubed and 7.75 times 10 to the power 3 gmm cubed. The volume and density of glass block have been determined, which are 159.49 cm3 and 1.9073 gcm to the power of 33.
Alright, so next we will be continuing for the experiment 5 is Hooke's law. Okay, for the objectives of the experiment is to verify the accuracy of Hooke's law. The apparatus is helical steel, spring with supportive stand and scale. The next is set of solid weight with hanger and also weight balance. Alright, next I will be continue. The next slide is procedure. The first one is the mass of the hanger was measured and recorded as M hanger. The weight of the hanger was calculated and recorded as W in the table. The scale was adjusted so the pointer of the hanger is nearer the upper end of the scale when unloaded. The position was recorded as X note. The hanger was loaded with 10 gram mass. The scale reading was recorded as X1. The eight data of the point were obtained by increasing the load with suitable increment equal before the end of the scale was reached. All the data were recorded with W and S1. The next is the process will reverse with the same load as in 3 unloaded. The new scale reading S1 for each load were recorded again. Extension of the spring was calculated as delta S, and the extension of the force acted on the spring F for each total load were determined. Alright, the next one is the result of the experiment data. Alright, this is our analysis of the data. The graph is based on the table that we have.
Next, we will move on to the discussion. The motion of an object that moves back and forth is defined as a simple harmonic motion that exists with a restoring force F that is opposite and directly proportional to the distance x that the object is displaced from the equilibrium position. This relationship can be written as such as the formula that display on the screen, where k is constant of proportionally with the minus sign indicate to the force is again the displacement and toward the equilibrium position. An elastic spring subject to a stretching force F that will be stretched from the equilibrium position by x amount according to Hooke's law until the spring force pull it back when it's stretched. When an object hand to the spring and it let equilibrium, total force act on its zero, hence with Fy is the force on the y-axis. Based on the result, on this experiment, we use a spring with 0.13 meter without load attached to attaching the spring with a hanger with a mass of 0.10 kilogram. When the added 0.01 kilogram mass on the hanger and then scale the spring extension, as we continue adding more mass onto the hanger, we notice a trend emerging as more and more mass and weight is added to the spring. The more extension force we created, thus increasing the extension of the spring from its original scale. Furthermore, another trend we notice based on our result on the scale reading with load. The scale increased with a 0.05 meter whenever the total load mass and hanger is over 0.02 kilogram. When it adds 0.02 kilogram, the extension of the spring from its original reading without load is 0.010 meter. With this average scale reading at 0.140 meter. But when 0.03 kilogram is used, the extension of the spring becomes 0.015 meter, a 0.05 meter encasement compared to the 0.010 meter increment previously. This trend continued to the subsequent extension of the spring received a 0.005 increment until 0.08 kilogram total mass loaded and hanger is used. This trend also affected the scale reading with load. At the first average we get is 0.140 before it increased to 0.145 meter, 0.15 meter, 0.155 meter until the final reading is at 0.175 meter. For this experiment, we have produced a graph graph is the force causing at the extension F against the extension X. From the graph, we are able to calculate the gradient by using coordinate of origin 0, 0 and coordinate on the data we receive from the experiment, which is 0.025 and 0.5, in which we get the gradient of 20 nanometer. The gradient in this graph represents spring constant as K. All data that we have collected are valid as the fit inside the line created from the origin. This shows that our data meet the expected result for this experiment. From this graph, we can see that the force causing extension increase alongside the extension of the spring. This shows that they are directly proportional with each other. Next is, while performing this experiment, some source of error have been detected by us. Even though this error did not affect our result, it is important to be aware of them to ensure the experiment is conducted correctly. The operator must be aware what unit of measurement is to be used. This is important as the measurement used by the apparatus, weight, balance, and scale, are not in SI unit and thus need to be converted. Secondly, the operator must know how to properly read the scale in order to get the correct measurement of the spring extension. Spring extension. Since there is a gap between the spring and the scale, there is a change for the operator. There is a chance for the operator to read the wrong measurement. Thirdly, is the operator need to make sure the spring is in a good condition, where and here and the spring could cause the result is skewed from the predicted results. Next one is questions. The first question is, plot a graph of the focus causing the extension f against extension x. Calculate the gradient of the graph. What value does the gradient represent? Okay, so the gradient of the graph is 20 nanometer. The gradient represented in the spring constant is k. Question number 2 is, how much work done in stretching the spring through 0.20 meter? Find this form of the graph. So the answer has been displayed on the screen. So the next one is question 3. How much energy stored in the spring when it extends to 0.20 meter? So the answer is on the screen display. Next is question number 4. Describe any error that may have occurred during this experiment. So the error that may have occurred during this experiment are systematic error from the user that failed to read the length of the spring correctly. Second, the incorrect usage of measurement unit, as example, failure to convert the mass of the hanger from G to kg. Question number 5 is, what can you describe from your result about the relationship between the extension of spring and the force causing extension? So the answer is, the extension of spring is directly proportional to the force causing the extension. Therefore, there is extension of spring increase. The force causing the extension is also increased. So the last one is conclusion. So the conclusion is, Hooke's law accuracy have verified to be true based on this experiment that we have conducted. So that is the end of our presentation. Thank you so much for paying attention in our presentation. I hope all of you get something from our video. Thank you so much.